Thanks for coming here to listen to me. I'm going to talk today about building a culture of code quality within your organization. It's a bit of a change up from, you might have seen, I was going to do a different talk, but I switched it up, and we're going to talk about this. And then the other stuff, I'm going to make some cool blog posts about. So if you're interested in that, patterns of enterprise application architecture, check out the Code Climate blog. Like we said, I started a company called Code Climate about 2.5 years ago now. How many of you have heard of Code Climate? Cool, that's awesome. How many of you actually have paying Code Climate subscriptions? Cool, you guys are all my best friends. So the warning for this talk is that there's actually, it's kind of like the opposite of the talk that we saw right before lunch. There's zero code, there's no Ruby. It's going to be hopefully a inspiring sort of practical talk in terms of practices that you can bring back to your team, and maybe a good way to kick us off following everybody's tasty lunch that they had. We were at Flatbread, which was awesome, and now I'm a little sleepy, but we're going to do this stuff. So no code. OK, I want to talk about a term called presenting problems. This is from the medical community, and it means the initial symptom that caused a patient to consult a practitioner. So if your joint hurts, your elbow hurts, you might go to your doctor and say, hey, my elbow hurts. What could be going on here? And your doctor will do a bunch of tests and try to figure out what's going on and help you. But there's probably something underlying that that's going on. But the presenting problem is just your elbow hurts and you know that, and you want that to go away. So this applies to things outside of medicine as well. And in software, there are a number of presenting problems that can occur if you're not keeping the quality of your code base up to where it needs to be given your context. So the first presenting problem would be slow progress. I'm sure none of you guys have experienced this, but you probably know somebody who has. And that's when it feels like your project is kind of stuck in the mud. You try to hammer harder and harder to get features done, but you're fighting your code base at every turn, right? That can be a presenting problem of poor software quality. Another one, and this is near and dear to my heart as a New Yorker, is bugs. You might find that every time you introduce a change into your code base, in unpredictable ways, things are breaking. And that can be a sign of poor software quality. And then, after you introduce the bugs, you might feel like you have to play a game of whack-a-mole every time in order to fix them. So you go to fix that first bug, and then some other bug pops up in some other place that you couldn't have anticipated and is kind of staring at you, laughing at you. And you go to hit that one, and then another one pops up. So you get this kind of feeling that you're playing whack-a-mole with your code base. So these are all problems with poor quality, and it can lead to a vicious cycle. A lot of things around software quality, both positive and negative, as we're going to see, tend to be cyclic and build on each other. Usually, with poor code quality, it starts with pressure. So the business, for one reason or another, probably committed to doing something, some effectively fixed amount of work by a fixed amount of time, right? Usually it's that guy in sales who you kind of don't quite trust, and he commits to some prospective customer that you're going to build every feature under the sun in exactly 6 weeks. And in some cases, that is a terrible idea. And in some cases, though, it actually may be appropriate for the business to do that. Perhaps the alternative was the business going out of, the whole business ceasing to exist. So you can justify that in certain circumstances. The problem is developers tend to write their worst code when they're under a deadline. So when you start with pressure, what you end up with is usually slop. And I'm drawing a distinction between the term technical debt and slop. I think they mean two different things. We can talk about that if there's time for Q&A afterwards, but go with me on this for now. The pressure leads to sloppy code. And the sloppy code leads you to actually be late, right? Everybody knows that it's harder to get things done effectively in a difficult to maintain code base than it is in a clean code base. The problem is now this feeds back into it, right? So because you're now late on things, more pressure is building to get more and more done. And this cycle can kind of just continue on and on until things kind of spiral out of control. So I'm sure all of you guys have kind of felt this at one point or another in your software development career, if not on the project that you're on currently. So the thing to be aware of with software quality is everything is working against you. There's going to be changes that are coming down the pipe. They could be business changes. A lot of us work in organizations that have a great amount of uncertainty in terms of what you're doing. It could be a startup. It could be a new project inside of a larger company. But maybe you're not quite sure how it's going to make money yet. And the business has to keep iterating and pivoting in order to figure that out. And that has wear and tear on the code base. Also, a lot of us are changing our technologies at much faster rates than developers were in previous generations. So maybe we're switching something from maybe we have to do something that's raffle scale and switch from a SQL to a NoSQL solution. That kind of thing can have drag on your code base quality over time. And finally, given enough time, it's almost impossible to avoid changes to your team. Right? So people are moving on to other projects within the same organization. People are moving into different organizations. And also, frankly, not everybody's able to only hire senior software engineers, despite the fact that that seems to be what everybody wants to do all the time. Sometimes you have to take developers who have a good approach and have a basic level of experience and train them on the job in actually doing things the right way. But if you don't take a very active role in doing that, the results are fairly predictable, which is that it's going to pull the quality of your code base down because that person might be doing their best, but they just don't have as much experience as the people who started the project in the beginning. So I want to dive into a little bit in specific about the kind of factors that can lead to an unmaintainable code base at a source code level. So this is a diagram that a guy named David Peterson put on his blog a while back, and it hasn't gotten much attention, but I really love it. So I want to dig into it now, and you can check it out on his blog with the full post. Basically, if you start at the bottom, there's this beginning part here that developers on the left, developers do not want to introduce bugs, right? None of us in this room want to introduce bugs into our code base. So that's pretty much true, not really easy to debate. But it's also true that it's easy to introduce a bug when you're changing code, right? We all know that. We kind of have that intuition. So therefore, as developers, we often take changes to minimize the changes to existing code. And that in and of itself is not a problem. However, to minimize, when we're taking care to minimize changes to existing code, we might also realize that working on a copy of the code means you don't have to change the original. So rather than modifying something in the core logic of your application, where you know if it breaks it's going to be a big problem, maybe you copy and paste some of that logic to avoid changing that code path and just work over here in kind of your own silo. Therefore, you're going to introduce duplication into the code, but there's a reason why. At the same time, if you put conditional logic around new code, it reduces the chance of breaking the existing code, right? So maybe you're not copying and pasting something, but you can just block off a code path using conditionals and just route only the case that you care about through your new code to avoid breaking the rest of it, right? This in and of itself is not a problem, but let's look at the whole picture. Therefore, since the code is full of duplication, and now you're adding more conditional logic liberally throughout the application, and conditional logic actually makes it more difficult to understand the code becomes complex. And complex code makes it difficult to understand the ramifications of any change that you're about to make. Therefore, it goes back to the beginning. If it's difficult to understand the changes that you're about to make, you're going to feel like it's easy to introduce bugs, and you're right back into the beginning of this. So all of these are fairly innocuous, sort of small intuitions that developers have, not even necessarily consciously as they're iterating on code, but you can see how this plays out and leads to a more difficult to maintain code base over time. So you have to be really proactive to avoid this sort of thing. OK, so if you don't avoid that sort of thing, you end up with a very specific ailment, which is known as legacy code. And I just wanted to define that for everybody. Legacy code is actually a noun. It means code written by somebody else, or code written by you more than 2 weeks ago. That's the formal definition of legacy code. So you want to avoid legacy code. And hope is not a plan. So time and time again, I've seen good developers with good intentions embark on their next project, and they think to themselves, man, that last code base I was stuck maintaining was really a drag. I didn't feel like I could get anything done. I wasn't happy. We've already heard during this conference how important it can be to approach things from a standpoint of calm and reason and happiness and sort of be engaged in your work. But you have that code base that didn't give you any of those feelings. You say, oh, this was awful, awful, awful. I can't wait to get off that project. And then you say, OK, we're going to start a new project. It's going to be different this time. What's going to be different exactly? It's just a matter of time, in all likelihood, before your new project ends up just like your old project, if your only plan is hoping that it's going to be better this time. So I prefer the version of this from Einstein, which is insanity is doing the same thing over and over again and expecting different results. And I feel like that's where we've kind of plateaued with code quality, more or less. We do some things, we might test, we might pair, we might do retrospectives, we might do bits and pieces of these things, but many teams are stuck both realizing that their current situation is untenable, and then if you were to give them a clean slate tomorrow, they wouldn't do anything that much differently. So that's what I want to attack today, very aggressively, from the standpoint of what are practical things we can do to turn this on its head a little bit, or even give ourselves an incrementally better chance that our project will be more maintainable for a longer period of time. So before that, I want to do you guys all a giant favor and present to you the universal solution to any problem. You guys are going to thank me for this. It's actually 2 steps, very simply. Number 1, you're going to assemble information, and number 2, you're going to act on information. So you're welcome. Feel free to apply that in all of your future life. But in the case of code quality, there are a number of different types of information that we can collect when we realize we have a problem. I like to break things down into qualitative and quantitative when I'm thinking about data. So to start with qualitative information, if you are working in a team environment, I'm basically going to assume you're working in a team for the remainder of this talk. So if you're solo, you're going to kind of have to adopt this. But one-on-ones, I think, are a key way to collect qualitative information about the software development process and the software quality within your organization. So if you're a manager, if you have direct reports, I strongly encourage you to have a regular cycle of one-on-ones with all of your employees and talk about things like, hey, do you feel like the quality of the code is getting better or worse this week, and why? And maybe there are ways that your employee could be contributing more to the overall value of the code base. Maybe you say something like, hey, I noticed that whenever we whiteboard things, you have some really good ideas about how we architect the system. Why don't we do some more of that? What's holding us back from doing more of that? So you make the feedback process much more natural. It's not just like this big annual review where you're kind of worrying like, am I going to get fired or a 10% raise? Not sure. And you do that more naturally. And the other one would be retrospective. So this is kind of the same thing in the form of your team, right? You get everybody together, you look at work that was done over the past period of time, figure out what went well and what didn't go well, and build on it. So if code quality is an issue that you're facing, that can be a key topic of conversation in your retrospectives. Retros are probably the #1 thing I recommend to teams who come to me and say, we feel like we have code quality issues, or we have issues somewhere in our stack. We're not shipping things fast enough. We have bugs, whatever those presenting problems are. I say, well, do you have retrospectives? And usually they say something like, no, we don't feel like we have any time for retrospectives, which is ironic because the times when retrospectives are most important are exactly the times when you feel like you don't have enough time for them. So make that time sacred and get the right people in the room. In terms of quantitative data, there's some other things that you can do. You can collect process metrics. Velocity seems to be the most common, even though I hate that term. Lead time, cycle time are sort of concepts from lean manufacturing that people introduce in their software development processes. You can survey your team. I think this is a really simple and underused technique. It requires almost nothing. You can do it on paper, or you can do it with an email. But do an anonymous survey when you're approaching your deadline and ask your team, hey, how confident do you feel that we're going to hit our deadline? Send that out to everybody who has any sort of relation to the project and see what, in an anonymous way, and see what comes back. I bet you it's going to raise some alarm bells or teach you something really interesting about how much people actually feel you're going to hit that date, that everybody, when they're talking to each other, has to pretend like we're going to hit when you do something like that. And then you can collect software metrics. So there's lots of information that your code base can tell you. This is kind of near and dear to my heart because it's what Code Climate does, but there's lots of tools that do this. You can pull information directly out of your code base and figure out things like, how is the quality of the code base trending over time from a sort of analytical standpoint. OK, so if you've collected this information, now you have a better idea of the dynamics that are going on within your team that are causing the quality of your code base to be poor and potentially maybe be declining. Right? So there's lots of different reasons that could be, and they're going to be specific to your organization. But if you start to understand that, then you can figure out how to fix it. So I'm going to go through some different ways that you might be able to start chipping away at that problem depending on the specific issues that you're facing. First off, there's no silver bullets. Everybody's been kind of searching for silver bullets with respect to code quality for a long time. and they just don't exist. So everything that you can do towards code quality is going to be incremental, and a lot of times you get synergy from approaching a problem like this in multiple different ways. But so there's two basic steps that I would approach. If you realize that you're in a hole, then what's the first thing you should do? Stop digging, right? So first, do no harm. I hear this all the time from teams. They'll say, we can't really work on code quality right now because we know we have this huge problem. Like everybody knows that code quality is a problem for us, but we just can't approach that right now. It's this huge problem. But a lot of those same teams, what they don't realize is, I would bet that there are still additional new code quality problems being introduced into those code bases on a daily basis as they're in that state where they feel like they can't address code quality. So the first thing to do is stop introducing new problems, because they're almost certainly happening. And that's going to mean that when you do have time, when you do feel like you're in the right position to start digging out, you're not even deeper in the hole than you were when you had the realization that you're in a hole. Second side of things is the Boy Scout rule. So who knows what the Boy Scout rule is? There has to be one person. Is it? Yeah.
Leave the campsite cleaner than...
You found it. Right. Leave the campsite cleaner than you found it. So this applies very directly to code, I think. If you have a code quality problem and you stop introducing new issues and stop making the existing issues worse, then the question becomes, well, how do you get back on track? And I think the Boy Scout rule is the foundation of an answer to that. So every time you go into your code base, or someone on your team goes into your code base, try to just make one small improvement that you didn't have to necessarily do to get your job done, an elective improvement. And it could be as simple as taking a piece of code and rewriting it to conform to your team's established coding conventions that everyone's on the same page with. Or it could be extracting a single method from a complex class. And if you do this over time, if you do both of those things, your code quality can only trend in one direction, which is up, right? Because it's not getting any worse, and you're starting to chip away at it. Now, it may take a long time, but it's going to be moving in the right direction. So let's look at some specific things you can do if you want to apply those techniques to address the types of problems you might have in your team in putting those to work. One example that can be common, especially with teams with mixed experience levels, is that there's not enough refactoring experience throughout the team. Maybe the engineers who have a bit more experience, who have been doing software development or Ruby for a longer period of time, can more naturally see ways to refactor things. But it takes a while to actually drill that into your head to the point where when you look at a piece of code, you're immediately thinking about ways that it could be slightly cleaner, these kind of micro refactorings, right? So what can you do about that? There's a couple of concepts, a couple ideas I have. They're nothing revolutionary. But one would just be to do lunch and learn sessions. So I've had a lot of success with doing this in various organizations. But basically, the beauty of everything today is all of these talks are recorded, right? Like you can watch, you can have your team sort of be virtually attend any conference they want to, by the way of like going onto the Confreaks website and pulling down talks. So pick a talk which is related to the types of problems your team is facing, get together over a pizza that the company buys and watch a talk over lunch, and then after that, discuss how the concepts that are presented might relate to your current project. You can discuss an article or a blog post similarly, have people read it and come in. And if you're doing something like this, I highly recommend rotating the format so it doesn't get stale, and also the lead, which is important. So a natural thing to do might be to always have your VP of engineering or your team lead or the senior software engineers sort of leading these exercises. But I feel like it's even more helpful to rotate that responsibility around so that everybody on the team feels like they're responsible for the education of the team, including the most junior members of the team. They might not have all the answers, but they can at least pick out interesting things for the team to discuss and facilitate a conversation. The other side of it is this concept, this term I'm going to coin called Teamfactoring. So the idea of Teamfactoring is you block off an hour and you get everybody in your team in front of a projector, and you do a group refactoring session. You have one person driving, and you have maybe 4 or 5 people that are navigating from a pair programming standpoint, which initially sounds crazy. You're like, how can you get anything done like that? And you can't really get much done like that, except that you can have a bunch of really interesting conversations that everybody is in the room to hear, right? So if you pull up a piece of code which everyone knows is a problem in the code base, you can do a team factoring session, sit down and say, OK, how can we improve this? And at the end of the hour, you might not have an improvement to the code that you're ready to ship to production, but that's OK. The value in this context comes from the conversations that are going to happen between everybody on the team. You might have a senior guy saying, hey, we've ran into this sort of issue before, and here's 2 ways we solved it. And here was the problems we ran into with each of those ways, and here's what worked best. Or you might just have it might just create a floor for the more junior members of the team to ask questions about why it ended up like that in the first place, and expose more information that's kind of obscured in the code base. If your code is not ready to ship to prod with green tests at the end of this hour session, just throw it away, because that wasn't the point. What you don't want to do is do one of these sessions and end up with this like chore to finish refactoring the user class that's going to take 3 hours and never really ship anyway. Just throw it out, git checkout -- hard, reset -- hard, and move on to the next thing. But enjoy the conversations. And then again, you can rotate the area of the code base that you're working on in the lead. OK. So another problem that you might run into if you are trying to take these practices to your team is that you're finding problems too late. And the solution to that, in many forms, is a kind of early warning system. So what is an early warning system? There's lots of ways that this is practical for software dev. So you could have, the most common is build failures, right? It means it's basically your build telling you, you introduced a bug, and you can't ignore this. You need to do something about this. It's also possible to set up early warning systems for things like bugs and software quality issues using things like static analysis tools, and things like security vulnerabilities using both dynamic and static analysis. You can have tools that scan your website every hour, and as soon as you introduce a cross-site scripting vulnerability, will ping you. So the reason it's important to find issues early is because that's when they're much easier to fix. If you find a problem in your code base right away, you still have that context in your mind about what you were doing when you introduced that problem, and it's much easier to just go in and make a change and resolve it. Whereas if it's been a month, the cost to doing that and the overhead to do it is going to be much higher, and it's going to be much less likely that something gets fixed. So in the case of a code quality issue, I think the apt quote is, broken gets fixed, crappy lasts forever, or something like that. So if you just have code quality problem and it's a month down the road, it's probably not ever going to get fixed, at least until somebody's working in that area of the code base again. Because it just doesn't make sense to stop everything and fix some area of the code that maybe is never going to get changed for the next year. So you want to find these issues earlier and then resolve them earlier. OK. And this is an example of the type of early warnings that you can get from tools. So you can have pipe stuff out to your team's campfire chat room that, OK, there's this new issue that we need to take a look at. This is an example from Code Climate, but there are lots of tools like Jenkins that you can wire in all sorts of plugins and get this information piped out to your team. And I highly recommend you check out those types of solutions. OK, so any talk about code quality with respect to a team is going to start to get into questions about code reviews. Now, I'm not going to cover pair programming at all in this talk because there's been a lot said about it, and people tend to have fairly well-formed opinions about pair programming. And it's certainly not for everybody. But I will talk a little bit about code reviews. This is a code review. If you can't read it, it's a little bit blurry. It says that the only valid measurement of code quality is WTFs per minute. And on the left side, you have an example of a code review session that's going very well, because they're only swearing a little bit. And then on the right side, you have an example of a code review session which is not quite going as well. And I feel like this is the idea that comes to mind of the average Rubyist when they think about the possibility of code review. This sounds terrible. Like, who wants to be in that room when this is going on, even in the room where it's going pretty well? It's just an uncomfortable situation for either the reviewer or the person whose code is being reviewed. So I'm going to try to change it up a little bit. Some of you might know who this is. This is my favorite Republican pundit, Frank Luntz. And Frank Luntz's job is to take things that don't sound appealing and come up with new names for them that sound appealing, and vice versa. So like estate tax becomes death tax and that kind of thing. So if Frank Luntz came to the Ruby community and saw people's impressions of the idea of code review, but realized that it would be valuable if they did code review, he might say that we're making a language error when we use the words formal code review. And instead, he would suggest an adjustment to that language, and we could call it GitHub pull requests. And then it would be cool, and people would actually do it. So we can thank Frank Luntz for that. So for the remainder, we're going to talk about GitHub pull requests. Forget about the code review thing. That's not what this is, except for this slide. So how do you make code reviews painless? I think there's 3 keys. You can do code reviews non-blocking so that the person who's writing the code doesn't need to stop everything that they're doing and wait for their code to be reviewed. You can make it asynchronous so that the reviewer doesn't have to actually be interacting with the person whose code is being reviewed in real time all the time. Now, it definitely makes sense to do that some of the time, but to start with, I think an asynchronous review makes sense, and then you can escalate to synchronous. Let's get in the same room and talk about this if necessary. And also opt-in. So not everything necessarily needs to be reviewed, right? And programmers hopefully can have a pretty good sense of when something needs a review and when it doesn't. Now, the appropriate amount of code to be reviewed will change over time and will vary per team, but that's exactly the kind of thing that you can discuss at, for example, your team's retrospective. Does it feel like we're reviewing code unnecessarily? Does it feel like there's code which is going in, which should have been reviewed, which wasn't? But let the person who's writing the code make the ultimate decision about whether they're going to submit it to a review process in the form of a GitHub pull request. And the reason that code review is so important is that you can't edit your own writing. So I do some writing, publish content from time to time, and I've also edited content that other people are going to publish. So I feel like I'm maybe somewhat capable of doing both, but I definitely can't edit my own writing. And the reason for that is that I was so emotionally connected and intellectually connected to the process of creating the original work that I can't actually take myself out of that and look at it from the perspective of how are other people going to interpret this, which is the key when you're getting edited, right? So this is why I think it's really important to have somebody review the code who wasn't involved in its creation. And it's also why I've even gone so far as to make the controversial suggestion that teams are doing pair programming also do code review, because both of the people who were in the pair who created the work had that same relationship with the code. But lots of people like to debate me about that. So when you're reviewing, what can you look for? I think there's 5 things of varying levels of importance. You can look for formatting. Hopefully that's very rarely an issue if you have good standards. Correctness, does it seem like it does the right thing? I would tend to rely more on your tests for that sort of thing. Scalability, hopefully the person who's writing it has already looked at, is this going to scale and be performant? Because that can be kind of difficult to know from just reading it. But sometimes you can catch things like, oh, that service is actually really slow. If you call it in a loop like that, you're going to be screwed. Security, near and dear to my heart. And the most important one for code reviews in this context, I think, is comprehension. So how easy is it to understand the concepts and the abstractions that were introduced by this change to the code or changed by this modification of the code to someone who didn't write the code? Like, do you get it? So by now, there are probably some of you who are sitting in the audience who are thinking, this is great. Like, I would love to improve the quality of our code at my team. I can't wait to get back to work on Monday and start applying these concepts. However, it may be the case that you might also have somebody in your mind who you're thinking, man, that guy is gonna hate it. If I start like suggesting that we do these things. He's just like not gonna be into it. He just wants to like get his work done, like pop something off the queue, do it, ship it, be done with it. Why are you bothering me, right? Does anybody ever worked with a guy like that? Yeah, most of us have, right? I've been that guy. So what do? So it's not an easy answer. I think there are 2 general ways to approach it. The first thing that I would do is I would give that person as much opportunity as possible to try process improvements or changes in a non-threatening way and see how they affect things. So you can take things into your workplace as experiments. You can say, you know what, I don't know if formal code review through GitHub pull request is right for us, but isn't it worth trying it for maybe 60 days? And at the end of those 60 days, we'll get back together in a retrospective and make a decision about whether we want to drop it, continue it, or change it. And I'm not saying like just pretend like it's an experiment even though you already know the answer is that you need to keep doing it. I'm saying like actually have real experiments. And that can make people who have workflows that they're comfortable with be more open to trying changes to them. And what you're hoping for is you can lock onto some process changes that actually have short-term benefits that are recognizable. So when you have conversations as a team, you can say things like, hey, you know how we introduced this system so that we get notified when the code quality starts to drop? Like that seems like that saved us from having these technical debt introducing new technical debt problems. And the guy who might be resistant might say, oh yeah, you're kind of right. I guess I kind of see that. And if you can build up those wins over time, they might get eventually sort of buy into this process. If that all doesn't work, it's very possible that you might need to make a change to your organization, and sort of that person might be a better fit in a different organization. There are lots of programming environments where those types of that type of approach, where the quality isn't as important, doesn't really matter. There are I'm sure a lot of projects and organizations that person could work in and probably be happier. So they would end up being happier, and the rest of your team would feel like a weight's been lifted off their shoulders, right? Because everybody in the back of their head is like, man, it makes it just so much harder to work when I'm like trying to do the right thing, and now I feel like I have to like justify why I'm doing the right thing all the time. Like this kind of sucks. So everybody might be happier in that case with the team and that person parting ways. Pardon?
Is that what Franklin says when he fires someone?
Is that what Franklin says?
I think it would be better for everyone, including you.
Yeah, I think it would be better for everyone, including you, if we agree to go our separate ways, which can be true in some cases. So wrapping up, what you're looking to do is flip that vicious cycle we saw earlier on its head. And what that means is you start with quality. You improve the quality of the code within your organization. Improved quality leads to satisfied developers. Satisfied developers and happy developers tend to be more engaged with the work that they're doing. Engaged people tend to be more responsible and behave in responsible ways with respect to the work that they're continuing to do. And responsible people write quality code. So you can flip that thing on its head, and now you have this virtuous cycle that's causing your code base to get better and better over time. And what you want is not to stop the world and go into this dark room for a month where you're doing nothing but refactoring and everyone's kind of wondering, are you ever going to get back to working on features? But you want small, sustainable improvements over time. So eventually, you end up back where you feel like you need to be as a project and as a team. That's all I've got. Thank you very much for your time and attention.